Hello, this is video 6 in our Snake 3D devlog, where we can now, if we look around anywhere we like, we can click and place these red dots, which are waypoints, and these are coded, scripted in that little snake's, the Mach 3, the Mach 3 script. So our last video, there was a tiny bug in which if I was like looking upwards, the waypoint would just be in front of me, but wouldn't be exactly in line of sight. So first thing I need to do before I ramble on and talk about something else, just show you how I corrected that. It was a very easy correction. Last video we renamed the player Snake Wizard. I don't know if you can see that, Snake Wizard at the top of our hierarchy. And what I forgot was the first-person controller script doesn't orientate the rotation of this game object's transform. Instead, it's got a child, which I've now renamed to the Snake Wizard Eyes. It's got a child, which is the camera, which is the actual game object that's looking around. So it's this transform's rotation that we need to look at in the script. Which is here. So we're back in the Mach 3 snake brain, and I forgot to look at the time. Just looked at the time. Okay, it's about past. And so all we do now is to set a new waypoint. We make sure that the waypoint fruit is active. So this is a game object that we've already loaded into the scene. And so when we click the button, click the mouse button down here, we call the place waypoint function, and we just set the waypoint to active, just in case it's the first time that we've clicked it. When we first load it into the scene, we set it inactive or set active to false, so we can't actually see it, we can't interact with that waypoint, which is just a sphere object with a red material on. Then we set its position to the player's transform position. We make sure that the rotation is exactly the same as the player. That shouldn't matter actually, so I'm going to comment this out. That shouldn't matter. And then we translate the waypoint fruit, the red sphere, forward, so that will be according to actually that does want to be according to the wizard eyes rotation. Actually, that forward will be inherited from this rotation, I think, and then times 5, which means 5 meters ahead. I've just chosen that arbitrarily. Okay, that's how that works. And so the only the big change from the last video, which is just, where are we? Oh yes. So in the start function, when we first load up the scene, our player transform is no longer Snake Wizard, but Snake Wizard Eyes. It's that transform, i.e. the child object, the camera, which does the mouse look thing, instead of the parent object. Okay, so we've got our waypoints being placed where we want them, but the big thing of this video, again I want to be about 20 minutes, it's a bit longer than that last time, is to do what we looked at last time, which is this stuff down here. So this is kind of a pseudo idea of how we're going to write this algorithm. So we're going to generate a random number between 1 and 3, including 1 and 3. And each of those numbers, 1, 2, and 3, will correspond to looking after a different axis, the x-axis, the y-axis, and the z-axis in space, in 3D space. And let's say we've chosen random number 2, and then the snake will say, okay, is the waypoint higher than me or lower than me? If it's higher, I'll make sure my direction is switched on to 2. If the waypoint is lower, I'll make sure my direction is 5, and then it'll start going down. And that's it, really. We do exactly the same for the z-axis and the x-axis. The only thing is, after we've decided that direction, we just need to check for, let's write this in red, we need to check that we don't go back through the body. I don't know how to represent that. I'm going to do a wiggly line, a snake head, and then going back through the body, a big cross. So this at the end, this represents we're not allowed to go back through the body. So we've already got an algorithm. I'll do a big circle around the dice. We've already got that taken care of with a little algorithm that says if our new direction, let's say we're moving down 5, we're moving down with the which direction or the which d variable equals 5, we make sure that the old direction wasn't 2. If it was, then we just have to do something else. And we'll have to decide what to do then. When it was just a random direction, we just said go and get another random direction. As long as it wasn't 5 again, you're okay. Perlin noise did something similar. So let's get coding. So we want to go and code this, basically. So firstly, let's go into the update function just to remind ourselves what's happening. So here we've just got some input. So we can place a waypoint by clicking left. If we click right, we shrink the snake. That was just for debugging purposes. Ideally, what we want to happen is when we hit the waypoint, when we gobble up the fruit, we want to grow the snake. Okay. So then we check, is it time to move? If it is, we move the snake, and then we check the direction after it. Okay, so it's in check direction that we want to go and do things. And that's quite a long function, so I think we'll do this. We'll say if the waypoint fruit is active, then we'll call it gobble chase. So gobble chase means go and try and gobble that fruit. Go and chase the fruit. Okay. Else, check direction. Okay, I think this makes sense. Let's just write a comment so we know what we're doing. So if a waypoint exists, go find it. Else, pick a random / Perlin direction, which we've already coded. So we need to not poke ourselves in the eye. We need to go and write our gobble chase function. Let's write it next to the check direction because we're going to borrow some of its logic, surely. Oh, actually, we want to kind of want to decide on the direction and then do this, rotate the snake. So maybe we'll put rotate snake in its own function in a little while. Okay, so down here, so we want to say void gobble chase. Is that what it's called? Go gobble chase? I think so. Right, gobble chase. So according to our plan, we want to choose a random number out of 3, which decides which axis snake will consider. So let's do that first. So we'll say int ax for axis equals random.range. I always forget what number is included and what's not. It says returns a random float number between a minimum inclusive and max inclusive. So minimum inclusive means 1 and 3. But I'm sure it never works out that way. I think it's because of converting that now to an integer. I think if we can just implicitly convert it like that. Okay, so we've got our random number. So let's write a switch. I forgot what you call it. No, it's not a function kind of thing. It's a switch case thing. Right, decision buddy. Switch ax. So we're looking at AX. Here's the body of our switch case thingy. And if the case is 1, then do this. I know, we'll just set a variable. So we'll say which axis equals 1. What am I doing? I'm just repeating myself. We need to write a whole function here, really. Okay. So if case is 1, we want to say if our snakes, what is that? What axis are we looking at? We are looking at the x-axis. Oh, can't see my face. Right, x-axis. Sorry, I just got a message here. Okay, just about the football. Arsenal have scored. Right, x-axis. What are we doing? Are we left or right? Turning right is 3. I'll keep that in mind. Okay, case 1, we're considering the x-axis. So are we turning left or right? So if this transform position, it might be better to store that in a variable at the top. If this transform position dot x is less than waypoint fruit position, is that transform dot position x then we need to, where are we? Sorry, if our snake is less on the x-axis, we want to turn right. So which d equals, and I've forgotten already which way is to turn right. To turn right is direction 3. Okay. Which direction? 3. Else, you know what? What if we found the right direction? We don't want to avoid the snake, avoid the fruit. So we're going to say else if. I'm going to copy all of this. Definitely should have stored this in a conveniently short variable. If it's greater than, so if the snake has passed the fruit on the x-axis, I need to put that final bracket there, then which d equals 4, this is going to turn left. Else, I'll just be very clear, but else if they're, I think I can just write, I know that it must be now lined up on the x-axis, else we want which direction to just carry on the way it's going, unless it's already going left or right. Else, let's just wrap. What should we do? What should we do? Else, we could make the snake go down, up, forwards, backwards. For now, let's just say what should we do? Okay, let's just make it go up into the air. That's what we'll do, default. Right, which d equals 5? Was 5 straight up in the air? 2 was straight up in the air. Which direction equals 2? Okay, so if we get any strange bugs later, it's probably that, I guess. Okay, so we've hopefully done the hard bit. And break. There we go. Okay, case 2. So case 2 was the y-axis. Oh, sorry about that. Another message. Score's going very well. Case 2, so that's considering the y-axis. 2 is up. Okay, so if the snake's y is less than, so if we're lower, then we want to be going up, which is 2. If our position is greater than, so higher than the waypoint fruit, we want to be going down, which is 5. Else, now we can't just go back up. Else, we are going to go in direction 1. Okay, so either we'll go up or forwards along the z-axis. Okay, so final one. Final case. Case 3. This considers the z-axis. So if our snake is behind the fruit on the z-axis, we want to be carrying on forward. So that's direction 1. The opposite direction must be 6, else we'll go straight up into the air, which is 2. And I need to make sure that I change these. The operators are fine as they are. Okay, that seems to make sense. So our snake should be able to decide to get closer to our fruit. So I think we're in a position to check this, because I know it might be able to go through its own body at the moment, but we just want to see whether the basic movement or chasing movement is okay. It's decided its direction, but it hasn't rotated itself. So now we need to, we'll call that steer snake, and we'll just paste into here the code we've already got. Steer snake. And we'll just remind ourselves what this function is doing. Rotate snake segments according to which D having just been decided. There we go. So we want to take yes, all of this code from the which direction. I'll leave that comment there. So we want to steer snake as well here. Drop that code in there. Okay, so everything should perform in the same way. Right, so we need to go and test this. About 6 minutes, I think, for this video. It'd be really nice if we've got some behavior where our Mach 3 snake can chase our waypoint, and every other Mach 3 snake that we create in the fountain will also chase the waypoint. So what I want to do is make sure that the snake 3, the Mach 3 snake, is ready and doesn't take a purlin path, because they'll all take the same path out the top of the fountain, if you remember from an earlier video. Right, save scenes, save project, and start. Right, first thing we can do is, as I showed you at the beginning of the video, we can now place our waypoints wherever we're looking. So here's our Mach 3 snake. So at the moment, there's no waypoint, so it can go and do what it likes. I can't remember whether it's purling noise or just randomly moving. But now if I put a waypoint here, he should make his way. The trouble is, I don't know where he is, so we can't see him making his way. Who's that over there? That one in the distance might be a random one. The Mach 2 snake, or the Mach 1 snake, whatever it was called. Okay, so it's taken quite a while. I've got two options. We can either make the floor invisible or go and make some more snakes now. I think we do both of those things. So press G and generate a load of snakes. Oh, press G again, else it'll make loads. So, they don't have waypoints. So they won't all be flying towards this waypoint, because each snake will have its own waypoint. So if I click now, each one of those snakes has a snake brain script on it, and they will all chase after this waypoint, which I've just made. But actually, I haven't just made one waypoint, there's lots and lots and lots of waypoints there. Okay, one of the snakes has gone pretty close. Another one's gone pretty close. Of course, nothing happens if they gobble the snake, if they get close. But they all should be, they're all pointing up. Now, we said we might get a bug in terms of the strange decision I made. In terms of, okay, if you're aligned on that random direction, X, Y, and Z, then just go up. So that's interesting. So it might be the case that we're generating the same. Let's make it again. I'm generating the same random number each time in our gobble chase. It's like, what do you call that thing in Christian religion? The ascension. This is like the snake ascension. They're all transcending to a metaphysical realm up there. What on earth is happening? Anyway, we need some debug lines. I need to stop the video in about 2 minutes, but let's just have a look and just see if there isn't anything obvious. So, steer snake, switch which D, so that is a public variable, or it has global scope, sorry, it has global scope, so that's fine. This we haven't changed. Okay, that's fine. The snakes seem to be moving fine before we interfered with our waypoint. So here's the waypoint, gobble chase. Choose a random number out of 3. So first we need a little debug here. Debug log. My gobble number is plus AX. So you should know what the gobble number is. Also, I want to just go and take off any other debug lines I've got. I think it's just the which direction. Yeah, algorithm. So we shouldn't be doing the check direction algorithm, sorry. Okay, let's just run that one more time. Should I make the ground? Yeah, I'll just while I mentioned it, let's go to the next folder up. It's this material. So if I go to, what do I need to go to? Standard, opaque, fade, and then choose a low albedo, a low alpha. We'll have kind of transparent ground now. So we can see where our little snakes, our naughty little snakes are going. Oh, also, snake 3, was that purlin? No, it was just randomly. It did just randomly go through the floor. So I put purlin noise on for him in terms of his path. Wow, that looks kind of like misty. That's kind of cool. Okay, so we can look through the floor now and see what's going on. Right, so here's our snake. So if I make a waypoint there, he burrows into the ground. and he is, at least now we can see him. It looks like he's just diving. Oh, debug log. I don't know if you can see it at the bottom of my recording. I think I just missed that off. It's not telling us that it's choosing a new direction each time. Just made a new waypoint. Okay. It's saying, all it's saying in the console is I should be changing direction, which might be to do with snake 2. Let's just turn off that snake. And just have a look where that other debug line is. Okay, we've commented it out in this brain, so it was the other snake that was reporting I should be changing direction. Is this okay? If step count equals step change, we should gobble chase. Okay, let's just run again and see what's going on. Okay, I'm running out of time. This will be the last check, I think. So, he's on a purlin path. Now, if I put the fruit here, okay, it's going back towards the fruit. My gobble number is 1, so that means the x-axis. My gobble number is 1. My gobble number is 1. Okay, there might be something wrong with the random number range. Okay, I said that was going to be the last time, but I'm just going to, I think I know what's wrong. I think I need to make sure that these are, no, that was fine. I was going to say they need to be floats, but they're working okay there. I was just going to say, maybe I just need to do this. Int AX. Which D equals? Don't know what's going on there. Oh, I know what's going on. Of course, this is pretty bad. Check direction. We set the step count to 0. So the step count doesn't keep going up. Because in our update, in our move snake, we increment the step count each time. The total steps goes up. But in the update loop, game loop, that's where we're checking. We're saying if there's a step, if the step count equals step change, then go and do this stuff. So one thing we might want to do, no, we should keep it exact like that. But we need to write the same kind of code in here. So really we need to, yeah, let's write that there. So step count equals 0. And then we can take that line out of here, because we're already doing it kind of explicitly now for both of the functions. Right, this might mean it works. But I'm interested how close a snake could get to the fruit. That'd be influenced by like how often it's changing direction. So it's got more of a chance. There we go, I've made the fruit. Ooh, it was kind of going back on itself, as it's allowed to do, which means it's kind of like circling that area, and it needs to try and turn right. My gobble number is 2, my gobble number is 1, my gobble number is 2, my gobble number is 1, my gobble number is 2. Okay, so as suspected, this range thing, which I always get wrong, I need to give it one more over here. 4. Okay, so it's not including the second parameter, as it seems to suggest in the instructions. So basically, it was just missing out one direction, one dimension of movement, one axis of movement. So let's just see if it works this time. So our snake's moving on that purlin path, so the same every time we run it. Place down our fruit, and it's snaking its way towards a fruit, and it went through, or very close to, the fruit. That's really cute. It's kind of attracted to this fruit. Okay, now that we've got, yeah, this is pretty much working. Now that we've got this working, we can do more interesting things, like have all of these snakes flock together, because we can use our waypoint system to say, I want you to kind of flock towards the average position of all the snakes. One of the snakes could kind of be the leader snake, and maybe all the snakes try to get close to that snake. If they get too close to one another, maybe they move off. Right, let's just see what happens, just to finish off. I've gone over the 20 minutes, I think, maybe into 35 minutes, something like that. Let's just place a waypoint over here. And remember, it's not just placing a single waypoint, although it'll look like that. It's placing a waypoint for every single snake, which might be a problem. We do want each snake to have a waypoint so that we can do sophisticated things later on in terms of the flocking behaviours and things like that. I kind of like the ground like this. It's kind of cool. We're moving away from kind of looking Minecrafty. I like the Minecraft look, but I also like this look a lot. It's a lot easier for, looking at snakes, spotting snakes underground. I think we also need our snakes to be kind of fluorescent. How do I do that? I'm not very, I don't know much about making kind of the bright colours through the code. I'll have to have a fiddle. Yes, here they go. All our snakes are making their way over to our fruit here. Also, we need something to happen when the snakes gobble up the fruit. That means we can also have snakes gobbling up each other. We could set a waypoint on each update loop to like the brain of another. The brain of another snake. We could have zombie snakes. Okay. This little mechanism has opened up many doors for us. So maybe I won't do a video for a while. This is like, what is this, the 6th video. So maybe I don't know if these videos are going to be very popular at all, but I'll look at them. They're loving the fruit over there. I'm getting involved as well. I can't, I'm protecting it. If these videos, I don't know, attract some comments, then I suppose I need to give people some time to see the videos and think about what they'd like to happen. Right, but there we go. We've got our snakes crowding around a waypoint, and we can set a new one over here, and over they go. So what I'm going to play around with is increasing how quickly our snakes move, so we can get some like flocking kind of behaviour going on. Okay, thank you very much. There we go. Goodbye. Maybe see you next time. Goodbye, Pixel Sun.